Trigonometry, areas of triangles. There are two methods for calculating the area of triangles. The first uses a formula. Area is 1 over 2 AB sine C, or 1 over 2 BC sine A, or 1 over 2 AC sine B. This is effectively the same formula. It just takes two lengths, A and B in this case, and the shared angle between them. Two lengths and the shared angle between them. Two lengths and the shared angle. So you can start with any two letters, if you have them, any two sides where the lengths are known and the angle is known, the shared angle between them, you can calculate the sine. A different approach uses the area of a triangle using half the base by the perpendicular height. Useful where there's a 90-degree angle in the triangle, but it can be found in all cases. Example 1. Find the area of the given triangle. When you look at the triangle, well, it's not a right angle triangle, there's no indication of a right angle. Two of the lengths are known, and the angle between them, the two lengths, the angle they share in common, is also known. So it looks like the formula for the area of the triangle is a useful formula to use. So the area is given by half of AB sine C, or half of BC sine A, or half of AC sine B. But if we look at the letters we know B and we know C, and the angle A. So we're interested in the part of it where it's 1 over 2 BC sine A. That's the formula we'll use. It's now a question of substituting the values. B we know to be 12, so half of BC is a half, B is 12, we bring that down, C 12.81, we substitute here, and sine A is the angle A, 38.66, sine of 38.66. With the calculator, 38.66 in the calculator, pressing the sine function, we get 0.624697. So continuing now, using the formula half of BC sine A, the area is half of B, 12, C, 12.81, and sine of A we found to be 0.624697. Multiplying all of those across, we get the area of the triangle equal to 48. Example 2, finding the area. In this case, you're asked to find the area of the given triangle by calculating its base and perpendicular height. Here's the triangle. A, B, C are the angles. We have a length here of B of 12, this length here of 12.81, and we have no obvious perpendicular height. We'd have to drop a perpendicular from S, the top, down to Q, the midpoint, the point here. We don't know how far apart that is. We don't know how much of the 12 is to the left or to the right. We just know that we can drop a perpendicular and a 90-degree. The formula is given by half the base by the perpendicular height. Not knowing the perpendicular height, we just call that h for the moment. The base is not just to the end of where the perpendicular drops, but all the way. So the base is PR, to include the distance from P to Q plus the distance from Q to R. The full base length is 12. Now we return to the perpendicular height. How do we find this height, h? Well, we do know that the sine of the angle A is, well, we know the angle A is 38.66, and we know its sine is 0.624697. But sine is SOH. Sine is given as opposite over hypotenuse, sine opposite hypotenuse. And the opposite side to the angle A in the right angle triangle is the side with length h. So sine A is h over the hypotenuse, the one opposite the 90 degrees. So h over 12.81 is sine A. Sine A is h over 12.81, but it's also equal to 0.624697 because we know that A is 38.66 and we know its sine to be this value. So therefore h over 12.81 is 0.624697, and multiplying across, h is 12.81 times 0.624697. h is 8. So we've now identified the perpendicular height for this triangle. We also know its base. So using the formula, the area is half the base, half of the base, which is half of 12, times the perpendicular height, which is 8. The area turns out to be 48.